This is lesson 5.2 in geometry. We're looking at corresponding parts of congruent figures. So in 5.1, we looked at what it means for two things to be congruent. We studied how the two figures, if we're going to say they're congruent, have to be the result of some type of isometry. So that means a composition of reflections. Okay, the big idea today says that when figures are congruent, so we already have established they're congruent, they're the same size, they're the result of a reflection, a rotation, a translation, or a glide reflection. Those are all your isometries. So when they're all congruent, all corresponding parts, the angles, the segments, regions, all of that are individually congruent. So basically, if the whole figure is congruent, each individual piece can be singled out as congruent as well. Okay, so the first theorem we're going to look at today is the segment congruence theorem. It says if two segments are congruent, they have the same length. Okay, so we know distance is preserved when we're looking at these isometries. And so the length of a segment would be considered the distance. And so if we have two figures and two segments specifically in this case, and they're congruent, distance has been preserved, they have the same length. So in example number 1, we're looking at these two things. We know CL is congruent to AR. So we know that this length right here is equal to this length right here. Now, because we don't have the actual measurement, that's why we're saying congruent. If we knew this was 10 and this was 10, we would just say that they're equal to each other. So congruence basically is knowing that they're the same size without actually having the measurement. Okay, so we know they're the same size. We don't know how much they are. Now they're telling me that CA is 36. Okay, CA is made up of CL, this piece, let's call it X, plus LA. We don't know what that is. We also know that AR is the same size. And so they want you to find LR. And some of you might be able to just see it. But if we're taking this piece and adding this other one on, let's call it Y. And then we want to find this piece, that's X plus Y. This is LR. And so these have to be equal to each other because C to A is this piece X plus this piece Y. And LR, what we're looking for is this piece X, which is congruent to CL, the same size, plus Y. So it's the same thing, X plus Y, X plus Y. So we know that LR is going to be congruent to CA. We know that because it's made up of the same pieces. These are congruent to each other plus Y to make both of these. And so if CA has already been established as 36, then we know that LR also equals 36. If it doesn't make sense to you when you're looking at it with X's and Y's and all of that, substitute a number in here for CL. Let's say we know that this is 30. Well, they already told us CL and AR are congruent, so that means AR is also 30. Well, if this was 30 and this whole thing's 36, I know this must be 6 in here. So 30 plus 6 is 36. And now if they want you to find LR, we already know this was 30. It was given to us. It's congruent to this one. Okay, so if I'm finding LR, it's the 30 again plus this piece of 6. So it's 36 total. Again, those were made up numbers, but it just shows you how this works with all of those congruent pieces. All right, so that's just talking about congruent segments, meaning they are the same length. Angle congruence is the same thing. Two angles are congruent if and only if they have the same measure. Okay, so we would say that any two angles that are congruent have the exact same angle measure. So example number 2 here, the figure at the right, GOV, that's this whole big angle, which would be all of this space here. It's congruent to A and K, all of this right here. And OS right here bisects GOV. So the big GOV and the big ANK are equal, and this angle over here is getting split into two equal pieces. We know bisects means cuts perfectly in half. Okay, so now they say GOV, which we were talking about up here, is this, and ANK, which we were talking about up here, is this. They want you to find the angle measure of 1 over here. But first thing we need to do is solve for these bigger angles by solving for x. So what we know about ANK and GOV is that they're equal to each other. They're congruent, which means they have the same measure. So this one equals this and this one equals this. So how I set them up algebraically is that they're equal. GOV is congruent to, which means has the same measure as ANK. So this has to equal this. 12x minus 2 must equal 8x plus 34. And again, that comes from this. That's why I'm allowed to set it up like that. This one equals this because they told me they're congruent. Okay, I would just solve this. So minus 8x from both sides. So 4x minus 2 equals 34. Add 2. So 4x equals 36. Divide by 4. X equals 9. Now that doesn't answer the question. The measure of angle 1 is not 9. That's just what x equals. So to find the measure of angle 1, I need to use this bisects information and figure out what is this whole angle, and it's not 9. What is this whole angle, and then cut it in half, and that's what angle 1 is. So first of all, these two are equal to each other. So if I plug in x for this one, and I plug in x for this one, I better get the same answer because they're supposed to be equal to each other. So if I do 12 times 9 minus 2, I get 106. If I do 8 times 9 plus 34, I get 106. And you can run those numbers for yourself, or you can just trust me on that one. But those do come out equal. That tells me I did my math right. So if I have a number here and I plug it in and they don't come out equal, I messed up my algebra somewhere. I know they have to be equal, so one of my steps is off. So this whole angle is 106. This whole angle is 106. This angle that I'm looking for, the measure of angle 1, that's what I'm looking for, is going to be half of 106 because OS is bisecting the 106. It's cutting it into two equal pieces. So you're going to do 106 divided by 2, which is 53. So this angle is 53 and this angle is 53. And so the measure of angle 1 is 53 degrees. All right, so parts of figures that are images of each other under a transformation are called corresponding parts. So each one of these things is going to have corresponding parts. These can be sides, angles, diagonals, arcs, circles, rays. It can be a lot of stuff. It's all the different pieces that make up whatever it was that we reflected. So if the transformation is an isometry, which means it's a form of reflections, then any of the corresponding parts are automatically congruent because the definition of isometry, remember, A, B, C, D is all preserved. Okay, so that's why we know all of those pieces are going to be preserved. Angle measure, distance. All right, so when we're writing a proof, if we want to say, I know this piece equals this one, and you're asked to give a justification, this is what you're going to write, the corresponding parts in congruent figures theorem. Luckily, we're going to save you all that writing, and you can just write this. And so as we get into some proofs and we start writing them, you're going to use this justification a lot. So I knew that this shape was congruent to this one, so I know this angle is going to be congruent to this angle, and the reasoning is CPCF, corresponding parts of congruent figures are congruent. So it just says if two figures are congruent, then any of their parts, the corresponding parts, are also congruent. So let's go a little deeper with that and talk about what that means. So the figure at the right, we have quadrilateral MAPS, and that's the image of quadrilateral NICE. So if we look at this, it's flipped over a little bit. The orientation is off. This is not just a rotation. It's flipped and then it's slid up there. This is some kind of glide reflection. All right. It's not an obvious one where it just goes up and flips over. It's going to have a line that's, let's see, it's going to have to flip kind of this way. There's a line like this. And it's going to flip over and then it's going to slide up from there. Okay, so that's a glide reflection. But you can just tell the size hasn't changed. It's just the orientation. So it's either a reflection or a glide reflection, but it still means that it's an isometry, which means these are congruent to each other. So they tell you that this is under an isometry. So as soon as they tell you that you know they're congruent. And so they're going to say that maps is congruent to nice, or the transformation of maps when we transform it equals nice. When we write this, and here's the most important part, the corresponding vertices must be in order. They must match. So it just so happens that these two spell out, some words. So of course you would put the M first for MAPS. You wouldn't put APSM. Or over here you wouldn't put CIEN, right? If you were writing it out. But when we do write these out, we have to match up the corresponding angles, basically. So I think the easiest one to see here is angle E. If I told you where is angle E up here, you would say it's at S. You can see this is flipped and slid over there. This long, skinny piece of this shape is right here, right? It's flipped over there, which means C over here, okay, is going to match up with P, and so on and so forth. Now, that has to match up over here as well. So here's what we mean by that. The order that this has been written tells us that the transformation of M equals N. So if you look, M is the first letter, N is the first letter. So I know that those are matching. I don't even need the picture to tell me that. Okay, the picture kind of helps illustrate this a little bit, but if you're just given the statement like this, MAPS is congruent to NICE, I know the matching angles between these two, the image and the pre-image, is M and N. I also know whatever angle A is, because it's the second letter when I write this out and it matches the second letter over here, I know that A equals I. What does that mean? So if over here in the picture A was equal to, let's just make up, that's an obtuse angle there. Let's say that's 120 degrees. If A is 120 degrees, because it's in this position, I know I is going to match it. And so I know I is 120 degrees because those are the corresponding parts. Corresponding parts, as in angles, as in sides, corresponding parts of congruent figures, okay, are congruent. And so the third letter is P and C. So P and C are equal. So if this is 45, P is 45, I know C is also 45. Those are the matching corresponding parts. And then if E and S are the last letters written, I know that those are equal to each other. So those would have the same angle measure. So let's kind of practice with that if that was a little kind of too much at once. So given this, no picture, given that triangle TOP is congruent to triangle CAN, just by the way the letters are written, I can go ahead and list the corresponding angles and sides. So the angles that are going to be congruent here, if these two triangles are congruent or the same size, it's the image of the other one, the angles that are going to be equal are going to be in the same position. So angle T is going to be congruent to angle C because they're in the first position. Angle O in the middle position is going to be congruent to angle A. And then P and N, same thing. Angle P is congruent to angle N. Now that's just the angles. Let's list the corresponding sides. You can put these together in pieces. Okay, there's going to be, it's a triangle, 3 sides. The combination of the first two, TO, the combination of the second two, OP, and then the combination of the first and the last letter. So there's a side of this triangle that is TO. It's going to be congruent to, match it up over here. If that's the first 2 letters, it's going to match the first 2 letters over here, CA. Then there's going to be a side that's OP, and it's going to match the other 2 letters over here, AN. Notice I wrote the same order too, OP and then AN. So I wouldn't say NA. You want to make sure that they match up. I went second to third letter, so go second to third letter. Even though those distances, when you read it backwards, don't change, you want to keep these corresponding pieces all in the same order. And then the first and the last letter is my only other option. So TO together, OP together, and then TP, first and the third, it would be congruent to CN. So I can do all of that without a picture just by looking at this. Now for part B, it says to sketch a possible situation and mark the congruent angles inside. So I've actually already given you the picture here. So if we take a look, the sides are all matched up here. TP has the 1, and that means it matches CN. So if you take a look, TP and CN, those are equal to each other. If I had drawn the picture TOP, and I didn't draw this one exactly sitting the same way, you can tell this has got to be flipped a little bit, or just spun actually, more of like a rotation. This side's going to match this one. Go like that. TOP should match CAN. And so this side, because it has 2 markings, matches this side that has 2 markings. TO is congruent to CA. And then the one with 3 markings, they match each other as well. So I have OP and AN. Now, the original question, I added in the picture. You were supposed to kind of sketch the picture yourself. I wanted to kind of get you ahead of the game here. So they want you to mark the congruent angles and sides. So the sides are already marked. Let's do the angles now. So I know that just from up here, T equals C. So the way we're going to mark this is we're going to put those little loops. So T matches C. And that's how you say something's congruent if you don't know the angle measure. So if I knew that this was 130, then I would write 130. I don't know that, but I do know that they're congruent. They're the same size. They have the same angle measure. So I mark them like this. So I need to also say that O is congruent to A. So those are the same angle. Whatever this one is, if it's 45, this one's 45. Now I have to mark these differently than these ones because then I would be saying all 4 of these angles are the same. So what you do is you just add another loop. So O is going to have 2 loops and A is going to have 2 loops. So any angle I see with these 2 little arcs are going to be equal to each other, just like with these slashes. If it had 2 slashes, it's congruent to the 2 slashes. 1 slash, 1 slash. So my last angle, I know P and N, those are congruent to each other. So I'm going to put 3 arcs on that one, and I'm going to put 3 arcs on that one. And now if I just looked at this shape, I can tell which angles are congruent and which sides are congruent. Okay, so to put a bow on this and wrap it up, looking at the comparison between congruence and equality, they're very, very similar. Equality is when you actually know the measurement, basically. And congruence is just you know they're the same size. You don't know exactly what they are, but you know that the size is the same. So congruence, we say that the segments are just congruent, same size. Now, equality is when the segments have equal length. I actually know the length. This one's 5, this one's 5. They're equal. I don't know the size, but I know they're the same. They're congruent. The way you write that out is with a squiggle or with an equal sign. If you have congruent angles, you just know they're the same size. If you know the actual measure, you'll say they're equal angles. Angles with the same measure are equal. If they're exactly the same size, they do have the same measure, but if we don't know what those measures are, we say they're congruent. And you write it like this. Again, the little squiggle. Or over here, notice we use a little m. The measure of angle ABC is equal to the measure of angle DEF. And you can only say that if you know the measure, 50 degrees and 50 degrees. You don't know the measure, but you know they're the same size, like up here. You just say that they're congruent with a little squiggle.